Okay, so today we're talking about arithmetic sequence and linear functions. We're going to recognize arithmetic sequence and we're going to relate arithmetic sequence to linear functions. So during a 2,000-meter race, the coach of a women's crew team recorded the team's times at several intervals. At 400 meters, the time was 1 minute 32 seconds. At 800 meters, it was 3 minutes and 4 seconds, and so forth. So she recorded all the times. They completed the race with a time of 7 minutes and 40 seconds. Okay? So you can relate the pattern of team times to linear functions. A sequence is a set of numbers called the term of the sequence in a specific order. Look for a pattern in the information given for the women's crew team. Make a table to analyze the data. So we put a table together, the distance and the time. And when we look from time to time, when we just go from one to the other, they go up by 1 minute 32 seconds. So as the distance increases in regular intervals, so these increase by 400, okay? Same. So as the distance increases in regular intervals, the time increases by 1 minute 32 seconds. Since the difference between the successive terms is constant, this is an arithmetic sequence. The difference between the terms is called the common difference, or the D, okay? So this just simply says what an arithmetic sequence is. An arithmetic sequence is a numerical pattern that increases or decreases as a constant rate called the common difference. So for example, if we have 3, 5, 7, 9, 11, you look at the difference between each term, and that is the common difference. So D equals 2. 3 dots used with the sequence are called ellipses. That's these right here. They just indicate that there are more terms in the sequence that are not listed. In other words, it goes on and on. Okay? All right. So this first part says determine whether each sequence is an arithmetic sequence and then explain. So we have -4, -2, 0, 2. So we look for a pattern to begin with. In this case, we have a pattern of each time it increases by 2. So the difference between the terms in the sequence is constant. Therefore, the sequence is arithmetic. Now, when we look at B, we have 1/2, 5/8, 3/4, 13/16. Well, from the first term to the second term, we go up by 1/8. So you would really want to convert these to the same denominator so you could see. The next term goes by 1/8, but when you get to the third term, it goes up by 1/16. Well, since they're all not the same fraction, this is not an arithmetic sequence. The difference between terms is not constant. Okay? Well, let's look at 1a. So when we go from -6 to -22, we are actually increasing by 4. From -22 to -18, we are actually increasing by 4. And then again, from -18 to -14, we're increasing by 4. And since we are increasing, this is a sequence is arithmetic. Okay? Now when we look here, we go up by 3, we go up by 5, and this one we go up by 16? So the sequence is not arithmetic. Okay? So it's got to be even amounts. You can use the common difference of an arithmetic sequence to find the next term. Find the next 3 terms in the arithmetic sequence of 15, 9, 3, -3. So we start with finding the common difference. In this case, when we go term to term, the common difference is -6. So then all I have to do is start with the last term and add -6 each time. So -3, I add a -6, I get -9. -9, I add a -6, I get -15. -15, I add a -6, I get -21. So the next 3 terms in the sequence would be -9, -15, and -21. Okay, so you're just carrying that sequence out. Each term in an arithmetic sequence can be expressed in terms of the first term, a subscript 1, and the common difference, d. So if we look here, we have the first term, which would be represented as a subscript 1. That would just be in terms of a subscript, and d, it would just be a subscript 1, and an example with numbers would be 8. The second term would be a subscript 2. The third term, a subscript 3. The fourth term, same way, okay? And when you get to the nth term, it would be represented as a subscript to the nth, okay? Now, when you look at it as in terms of as an equation, so to speak, you would have for the second term, you would have the first term plus your common difference. Your third term would be the first term plus 2 times the common difference. The fourth term would be the first term plus 3 times the common difference. So you start seeing a pattern. And what you could come up with is the first term plus nth, or the nth term, minus 1 times d, okay? And then here are some numbers to look at that, on how you would calculate that out, okay? So for example, if the common difference was 3 and the first term was 8, it would be 8 plus 1 times 3, which would give me 11. 8 plus 2 times 3, which would give me 14. 8 plus 3 times 3, which would give me 17. And then if I wanted to know whatever term, I would have this equation here, and I could plug whatever term I wanted in for the n, and I would solve and get the value of that term. So the nth term of an arithmetic sequence with the first term of a subscript 1 and common difference of d is given by this formula right here, okay, where n is a positive integer. So we are to write an equation for the nth term of the arithmetic sequence. So we have negative 12, negative 8, negative 4, and 0. So we look at that and we look for a common difference. In this case, when we go from term to term, we are adding 4 each time. So I can look at this equation. I can plug the first term. So this is the first term in the list. So I plug that into A1, okay? And then my common difference, I plug into the D. And then I would have to distribute. So I'd have negative 12 plus 4 times n minus 4 times 1, which would be 4. Combine my like terms, and that would be 4n minus 16. And that's the equation to find any term in that list of terms, okay? So then it says find the 9th term. So I just have to take 9, plug it in for n, and solve. 4 times 9 is 36 minus 16. So the 9th term is 20, okay? Now it says graph the first 5 terms of the sequence. So I can use that equation. I could list out the terms. I could then solve it. That would tell me what the value of those terms is. So the first term was negative 12. The second term was negative 8. The third term is negative 4. The fourth term is 0, and the fifth term is 4. I can use the n and the a to the subscript n. I can use those as coordinates, and then I can use those to plot the graph, okay? And then lastly, which term in the sequence is 32? So now I have the value. I need to know which term it is in. So what I can do is take that 32, plug it in for the a to the nth, and then solve for n, for which term has that value. So add 16 to both sides, and I get 48 equals 4n. Divide both sides by 4, and n equals 12. So the 12th term would equal 32, okay? So arithmetic sequence and functions. So as you can see from the last example we just did, the graph of the first 5 terms of an arithmetic sequence lie on a line. An arithmetic sequence is a linear function in which n is the independent variable, a to the subscript n, is the dependent variable, and d is the slope. The formula can be rewritten as the function here, where n is a counting number. While the domain of most linear functions are all real numbers, in the example we just did, the domain of the function is the set of counting numbers, and the range of the function is the set of integers on the line. So for example, Marisol is mailing invitations to her quinceañero. The arithmetic sequence of 42 cents, 84 cents, $1.26, and $1.68, and on, represents the cost of postage. They want to write a function to represent this sequence. Well, we start by putting a list of terms. First term, second term, third term, fourth term. And we look for the difference. The difference between them all is it goes up by 42 cents. So that tells me the common difference is 42 cents. So then I can look at my formula to the nth term, and I can plug in the 0.42 for the first term, and my common difference is also 0.42. So then I distribute, and I get 0.42 plus 0.42 times n minus 0.42. Combine my like terms, 0.42 minus 0.42 simply leaves me with 0.42 times n, so the function would be f of n equals 0.42 n, okay? Then it tells me to graph the function and determine the domain. So the rate of change of the function is 0.42, so I can make a table and plot the points. So here are my different terms, and this is what my answer would be. So 1 times 0.42, 2 times 0.42, 3 times 0.42. Then I can use those. This would be my x, this would be my y, and I would plot those on the graph. So the domain of the function is the number of invitations Marcel mails. So however many invitations she mails, that would be my domain. And then so that would be 1, 2, 3, 4, ... or ellipse, okay? So this last part, you are to try your own and see how you do. There are 20 seats in the first row of the balcony of the auditorium. There are 22 seats in the second row, 24 in the third row, okay? So you should write a function to represent this sequence and then graph the function. Take a second and then come back and see how you did. Okay, so write a function that represents the sequence. So again, from 20, 21, or 22 and 24, those are the three terms that I have. Then that increases by 2, so that's my common difference. So my d would be 2. My first term is 20, so I plug those into the formula. 20 plus 2 times n, and then negative 1 times 2 is negative 2. Combine my like terms, and it would be 18 plus 2n, or 2n plus 18. So that would be my my function could be f of n equals 2n plus 18. Okay? Then graph the function. So to graph the function, I just simply put my terms, put the numbers, and then use those as coordinates to graph. That's all I got to do, and that would solve it. If you got any questions, let me know.